Okay, this is the one of question of Coulomb's law or electrostatic force here. We have F electrostatics equals to K times Q1 Q2 divided D square, where K is constant 9.0 times 10 to the power 9 in Newton meter square per Coulomb square. So we have several questions here. We have four. We will try to solve this question. Yeah. Okay, let we start from number one. Find the force between charge of 10.0 microcoulomb and negative 50.0 microcoulomb located 20.0 centimeter apart. Okay, F means Q1, Q2. This is Q1, yeah. This is Q1 and this is Q2. But in microcoulomb, same thing with 10 times 10 to the power negative 6. Yeah. And also this one, yeah. 50 times 10 to the power negative 6. And 20 centimeter we can change into 0.2 in meter, yeah, in meter. So number one we can say F equals to K Q1 Q2 divided D square. This is equals to 9 times 10 to the power of 9. And then Q1, yeah, this one, this is negative 6. 10 times 10 power negative 6, same thing with 10 power negative 5. Yeah, this is 10 power negative 5. And then 5 times 10 power negative 5 also. Yeah. And divided with D square. D we have 0.2. Yeah, 0.2 square. So from this we can calculate first. 9 times 5 equals to 45, yeah. Times 10 to the power of 9 negative 10 negative 1, is it? Yeah. And then 0.2 square equals to 0.04, or 4 times 10 to the power negative 2. Then so this same thing with 45 divided 0.4, yeah. We use calculator first. This 4.5, yeah. 4.5 divided 0.04 equals to 225 divided 2, or 112.5. This is 112.5 in Newton. Yeah, that's it. Okay, this is about electrostatic force, yeah, or sometimes we call it as the Coulomb's force, yeah, because Coulomb's is the scientist we admitted. Okay, question 2. Two squares have identical charge are 75 centimeter apart. The force between them is 0.30 Newton. What is magnitude of charge on each pair? Let X change charge. Okay. Here number 2. We still use formula F electrostatic equals to K Q1 Q2 divided D square. They have centimeter apart is distance, or D, yeah. Then they have a 0.30 Newton as the force, so we can put here 0.30, yeah, equals to K, yeah, K is constant, 9 times to the power of 9, yeah, this one. Then Q1 Q2, we need to find it, let X as the charge here, so means like X times X, then divided D square, D 75 centimeter, yeah, 0.75, yeah, in meter. So we can say here like x square is 0.3, yeah, times 0.75 square, yeah, divided 9 times 10 to the power of 9. How much is it in x square? 0.3 times 0.75 square divided 9. Okay. This is about 1875. 1, 2, 3, 18.75 times 10 to the power with 1, 2, 3, 12, negative 12. Yeah. Then, yeah, we root it. Yeah. X mean root of 18.75. Yeah, times 10 to the power of 9 to the power negative 12. This is equals to 4.33. This is about 4.3 times 10 to the power of negative 6, yeah, in Coulomb. So same thing with 4.3 micro Coulomb. Yeah, this is same thing with 4.3 micro Coulomb. That's it. Okay, done question 2. Then what can you tell about the charge sign on the spare? I think because this is in positive sign, so same thing, yeah, either positive or positive and negative. Yeah, the positive and positive or negative with negative. Yeah. Because like positive times with positive equals to positive, and then negative times with negative equals to positive also. Either positive, both of them positive, or both of them is negative. Okay, let's check question 3. Yeah, we have 4 questions. I hope finish this question. Number 3. Consider the electric force between a pair of charged particles a certain distance apart by Coulomb's law. Okay, if the charge of one of particle is doubled, the force is I think yeah, we still use this formula. Yeah, F equals to K Q1 Q2 divided D square. So when the doubled, F also doubled. Yeah, when Q1 like Q1 is 2 times Q for Q1 before, so A is doubled also. Yeah. One. And then B, yeah, if instead the charge of both particle is doubled, the force is this is doubled and doubled. Yeah. So 4 times, yeah, 4 times, it's like quadrupled. Yeah, this is like, yeah, quadruple. Yeah, this is 2 times, like 2 times, and then this is like 2 square. Then C, if instead the distance between the particle is doubled, the force becomes the distance between the particle doubles. Yeah, when d is doubles, it's mean like 1/4 of, yeah, because this is on the position below, like force inversely proportional with d square. So like this is inversely with 1/2 square. Yeah, this is 1/2 square. So force it will be 1/4 of 4b4. Yeah, 1/4. And if the distance is half, the charge of both particles are doubled. The force is distance half. Yeah, both particles are doubled, so force become, this is 4 times here of q, and then double of distance, sorry, a half of distance, so means a half square. Yeah, so 4 divided 1/4 become 16. Yeah. So this is 16 as grade. Yeah. That's it. Still this equation, yeah, from the Coulomb's law. Okay, one more number. Question 4. What is the distance between the spheres each with a charge of 2.5 times 10 to the power negative 6 Coulomb when the force between them is 0.5 Newton? Oh, we find the distance. Force is K Q1 Q2 divided D. We can like change D square means K Q1 Q2 divided F. Is it? Yeah, and then D root of this. Yeah, so D is root of K. K is 9 times 10 to the power of 9. Yeah, and then Q1 same thing, 2.5 times 10 to the power negative 6. Maybe we square it. Then force, we have force 0.5. Okay, we calculate first. This is 2.5 here. 9 times 2.5 square divided 0.5. 225 divided 2, or this is 112.5 times 9 negative 12 negative 3. Is it? Yeah, okay. Times 10 negative 3. Then D we root it. Yeah, we root, this is something with 0.1125. Yeah, divided. Okay, we root it. Oh, this is about 0.33 meter. Or sometimes if we use in centimeter, this is something with 33, yeah, centimeter. Okay, I think makes sense. Yeah, okay, that's it. Yeah. Thank you.